Okay. So actually, in the olden days and all, we have been using antennas for even for cell phone and radios. But nowadays, if you see, there is no antennas even in the cell phone. Okay, the antenna is fabricated in the board itself. The antenna is fabricated in the board itself. That is with help of this technology only. That is with help of this microstrip antenna or patch antenna. That means nowadays, modern days mobile antenna is microstrip antenna or patch antenna. Modern days mobile antenna. Okay, so nowadays we are using smartphone. In the smartphone we are having this microstrip antenna or patch antenna in general. Okay, so and what is the structure of the patch antenna? You take this is like a conductor. Okay, this is like a conductor. This conductor is present above the dielectric material, above the dielectric material. Okay, this is the dielectric material epsilon r. Okay, and this is the feed line. Okay, this is the feed line. Okay, and this one is conductor. This entire thing is surface conductor like this. Okay, and is like a conductor because above the dielectric conductor sheet is there. Above the dielectric conductor sheet is there. And because of this conductivity nature, definitely once if you pass the current, some electric field, something will be there. The field nature will go like this. Okay, field nature, electric field nature will be like this. Okay, and again, this is the length of the conductor. This is the length of the conductor. And this one is width of the conductor. This one is width of the conductor. Okay, and this is the height of this dielectric medium. This is the height of the dielectric medium, because again at what frequency this microstrip antenna has to operate, it all depends on what is W, what is L, what is your H, and what is your epsilon R value. Okay, and then what should be the bandwidth of operation, it all decided by these parameters. Okay, so and again in general the epsilon R value, okay, relative permittivity of the material that you are using has to be in between 2.2 to up to 12, 2.2 to 12. Okay, then why we are using this microstrip or patch antenna? Mainly, what is the advantage of this microstrip or patch antenna? Okay, due to small size and weight, due to small size and weight. That means what? This antenna can be fabricated in the board itself. Okay, mobile phone board itself. That's why we are using this antenna. Main aim is small size and weight. Then what is the limitation? What is the limitation? Okay, it has narrow beam width or bandwidth. Please make sure that whether it is beam width or bandwidth. I'm having confusion. Definitely narrow band only. I think it could have been narrow beam width. Please check it out. And the next one is, next important thing is, this is most important. Radiation only in the off plane. Radiation only in off plane. That means what? Radiation only half plane. That means what? It will radiate only in one direction. See, if this is your transmitting antenna, it will radiate upward only. It will not radiate downwards. That is the main problem here. Okay, this antenna will radiate only upward. Similarly, if you use this as a receiving antenna, it will receive signal only from upward, not from the downward. That is the another problem with this antenna. Radiation only in the half plane. Okay, now you are having a plane. Above the plane only it will radiate, or from above the plane only it will receive. Okay, below the plane it will not radiate or it will not receive. That is the limitation of this one. Then again you may have a doubt, whenever we are using cell phone, definitely this direction is definitely, it could be of any one direction. Then still we are getting the signal, cell phone signal. How? Okay sir, okay, what is my doubt? Say I am holding my phone like this. Okay, I am holding my phone like this. Okay, in this manner. Suppose if the signal comes from here, it's okay, no problem, I can get the signal. If suppose my tower is there, definitely the signal will come to backside. Then also I am getting the signal. Then also actually I should not get the signal as per this concept. then also I am getting the signal. How? கண்டுபிடிச்சு வைங்க. Okay, then what is the other application of this satellite? What is the other application? Okay, it is used in high performance aircraft. Okay, high performance aircraft. ஏன் வந்து ஹை பெர்ஃபார்மன்ஸ் ஏர்கிராஃப்ட்லாம் இதை யூஸ் பண்றாங்க? ஏர்கிராஃப்ட், ஏரோப்ளேன், ஓகே, ஹெலிகாப்டர், ஏன் அங்கெல்லாம் வந்து இதை யூஸ் பண்றாங்க? why we are not able to use other antennas means you cannot use other antennas there because of the stability, because you cannot have a dish there, because that will be moving at faster speed. If you put your dish outside, you think it of what will happen. That's the main problem. That's why you cannot have some big physical structure there whenever you are moving at a faster rate. So in those cases you can use microstrip antenna, and that too, that cover body of the aircraft itself will act as an antenna. That is the main idea. Body of the aircraft itself will act as a antenna. So high performance antenna, spacecraft, missile application, radar, telemetry, GPS, satellite communication. Okay, so these are all the application of the microstrip patch antenna. Okay, then next, you might have heard the name anechoic chamber. Can anybody tell me why we are using anechoic chamber?
To measure radiation pattern.
Yes, sir. What?
To measure radiation pattern of tested.
Okay, that's okay. Then okay, is there any other way to measure the radiation pattern? Yes, that's okay, because for measurement we are using anechoic chamber. Yes, sir. Okay.